So now the question is, what is the mathematical or analytical meaning of continuity of a function at a given point? So let us say that you have a function y is equal to f of x. So as you can see, physically, you can see that this function is continuous. There are no breakages in this graph. Now, what is the mathematical meaning of this? So you can very clearly see visually that there are no breakages whatsoever on this graph. So now what does this translate into in terms of mathematical expressions or mathematical equations? So now let us try to analyze the continuity of this graph at a point A. So let us take a point corresponding to x is equal to A. So corresponding to x is equal to A, this is the point on the graph. So as you can see, f of A, let us call this equal to L. That is the value of the function, the functional value of this graph at x is equal to A is L. Now if a function has to be continuous at this point, so what should happen is the limit of this function as x tends to A. So limit x tends to A plus f of x should also be equal to L. That is, as x tends to A from the right hand side, this function has to approach this value L, and limit x tends to A minus f of x should also tend to the functional value at x is equal to A. So if all the three happens, then we say that the function is continuous at x is equal to A. So what is the mathematical equation which ensures continuity? At x is equal to A, limit x tends to A plus f of x has to be equal to limit x tends to A minus f of x has to be equal to f of A. The right hand limit has to be equal to the left hand limit. That means the limit has to exist. So both these conditions ensure that the limit exists. So the limit has to exist and the limit has to be exactly equal to the functional value. So if the limit of the function is equal to the functional value, then we say that the function is continuous at that specific point. So this is the most important condition for this chapter. So most of the questions, 90% of the questions on this chapter depends on this formula. So this formula has to be remembered very nicely. So limit x tends to A plus f of x is equal to limit x tends to A minus f of x is equal to f of A. So I want you to write this a lot of times so that you get familiar with this formula. So this is the condition for continuity of a function at a given point. Now, what are the different cases where the function may not be continuous? So as you can see, if the graph of this function is, if a graph of some function is like this. So this is a point where f of x is not defined. Hollow dot means that f of x is not defined at this point. At this single point, at this point, the function is not defined. So obviously if the function is not defined, you have a small breakage there. Corresponding to this point, there is no image, there is no value of y. So the graph comes until this point, it has a small breakage and then it continues. So this is one example of discontinuity. So if f of A is not defined, so if a function is not defined at any specific point, it will be a point of discontinuity. Next, there is one more case. If the function is defined, but it is not same as the limiting value. At this point, both the right limit and left limit are reaching this point, but the functional value is somewhere else. So if limit exists, but limit is not equal to the functional value, then also the function is not continuous. That is, limit x tends to A, f of x is not equal to f of A, In this case, you get a graph like this. As you can very clearly see, there is a discontinuity here. So if the limit is not equal to the functional value, then also the function is discontinuous. And the third case is if the limit does not exist. It is the right limit is different, the left limit is different. So if you have something like this, graph like this, the right limit is tending to this value, the left limit is tending to this value. So the right limit is not equal to the left limit, hence the function is discontinuous. You can very clearly see the discontinuity. So if limit x tends to a plus f of x is not equal to limit x tends to a minus f of x, then also the function is discontinuous. So these are the major reasons for a function to be discontinuous. One is if the function is not defined at that point. The second is function is defined but it's not equal to the limit. And third is if the limits are not defined. That is, if the right limit is not same as the left limit. If the limits are not defined finitely. That is, if the right limit is not equal to left limit, then we also say that the function is discontinuous. Right? So if the function has to be discontinuous, if the function has to be continuous, limit x tends to a plus f of x should be equal to limit x tends to a minus f of x should be equal to the functional value. This is the most important condition of this chapter.